In this world, like we have discussed in previous chapters and previous lectures, there are a lot of things that you see that you may not be able to give answer to. The rain that is falling, the cloud that is forming, what is inside the cloud? Where is the lightning coming from? Have you ever considered or even think that the light coming from lightning, how was it formed? Where did it come from? Why is it that rain is able to fall on us directly without the sky that we are looking at falling on us? How did the rain get to start? At what level is it starting? What is happening in the space? So before all of this, we need to know so much about matters, about the constitution of our environment. What are those items? Even the air we breathe, we need to know the component. We need to know what it consists of. So the essence of this lecture is to begin to introduce us to all those areas. And calculations were deliberately left out of this lecture because the idea is to increase people's interest in physics without bothering them with calculations at the initial stage. If there is going to be any calculation, that will be left for future lectures. But at this rate, we'll be going to look at those interesting areas of physics where when you just listen to it or when you just think about it, you believe that these are the essential knowledge you're supposed to have as a human being living in this wonderful world. State of matter. What is matter? Early humans easily distinguish between materials that were used for making clothes, those that could be shaped into tools, or those that were good to eat. They gave these things names, such as cotton for cloth, fur for also those that covers the animal, iron or even stone for their tools, while rabbits or other animals like that for what they eat. However, they did not have our current understanding of the substances that made up those objects, although their thinking and classification formed the basis for the understanding of what we have today on this subject. Now, consequent upon this understanding, in 450 BC, Empedocles, a Greek pre-Socratic philosopher, declared that all things are composed of four initial elements. He said, earth, air, fire, and water. This assertion survived until the advent of modern physics and chemistry. Kudos for the contribution of all these early philosophers. Now, what exactly is matter? The dictionary say it is substance or substances for which any physical object consists or is composed. Nice definition, but you and I, in simple words, and in line with our age-long familiar definition, matter is anything that has mass and occupies space. This is the definition we have been carrying on our head since elementary school. We shall discuss four popular states of matter and dedicate a separate lecture to the understanding on the discussion of plasma. In doing this, we shall determine the state of matter by the strength of the bonds between atoms that make up those matters. Let me say here that atom is smaller than matter and even molecules. So, atom is the most smallest indivisible particle of an element. But for the purpose of this lecture, we are looking at matters and we are trying to describe what matter is all about. Now, matter exists in four states. If you look around you in the universe, you can always find any matter, any object in the following four states. It's either is solid, liquid, gas, or plasma. Although there are other state of matters, and of course up to 15 of them, but we shall limit our discussions to these 4. However, we will not discuss plasma at the same extent to which we are going to discuss the other 3. We will leave the discussion to another lecture where we look at plasma in details. Now, let's start with solid. And let me define each of these and discuss their characteristics. A solid is a state of matter that is characterized by particles arranged such that their shape and volume are relatively stable, as you can see. These are hard materials. This shape will remain the way it is. It can't change easily. Liquid. Liquid simply describes a state of matter in which the components, and the components are just components like water, alcohol, flow, and of course juice and milk and honey are also another example. So these are liquid. The third is a gas, and gas is defined as a state of matter consisting of particles that have neither volume nor shape defined. The third state of matter is very, very important, because beyond that third stage, we start talking of those stages that probably we cannot even interact with directly, but every object you see in this world will either belong to any of these. Now, for plasma, and for the purpose of definition, plasma is the fourth state of matter in which an ionized substance becomes highly electrical conductive to the point that long-range electric and magnetic fields dominate its behavior. Change of state of matter. A change of state of matter involves physically changing matter from one state to another. Usually, state of matter is changed by changing either temperature or pressure, or sometimes both. You have to change both temperature and pressure. Now, let's consider melting. Melting is one of the methods that is used to change the state of matter. You know, melting is used to change solid and convert its state to liquid, and the process is called melting, or is also called fusion. It is achieved by application of heat to solid. If you apply heat to solid seriously, you will see it melting, and of course it will turn to liquid. A very good example is when you heat ice block and you apply very big heat to ice block, you will see it melting, and then it converts to water. But the good thing is that these are also reversible process. You can also convert it back to ice. And what do? You just subject the water to a very low temperature by putting it in a freezer, for instance, and then it will freeze and convert to solid again. Now, boiling, you can use boiling to convert liquid to gas. If you have gas, of course, if you have liquid and you apply heat, it will come to a point where you see vapor coming out. That vapor is a gas. So, with a very high temperature, those temperatures above boiling point, you can convert it. So, the inverse of this, of course, you can also convert it back, and that one is called condensation, and it's exactly the reverse of boiling itself, whereby you now lower the temperature seriously, and you see all those gases turning into liquid again and dropping back into your container. Finally, we have sublimation. Sublimation is a case where you convert solid directly into vapor upon heating. The reverse of sublimation is called deposition, and in that case, vapor is directly converted to solid. So what I'm going to say about all this is, these are processes that you use to convert one form of matter to another. And why we need to have this knowledge around this time is because I will also delve into space science in the future of my lecture, and it will not be good enough if you don't familiarize yourself with matters when we are discussing that, so that you'll be able to refer to your knowledge in this particular lecture. Because the earth we live in, whatever you find in the earth cannot go beyond all these states of matter, like I've mentioned. But of course, like I said, I've suspended the discussion on plasma till next lecture. So I hope you enjoy this lecture, and of course, and I believe that you are well prepared to listen to the rest of my lecture, which will border on space science, rockets, and all that, and use the knowledge you have here as a background to understanding whatever I'm talking about there. So I would like you to watch out for my next lecture, and then once again subscribe, like this page, so that you can be notified when those subjects come to you. The aim of this lecture is to make science and physics as simple as possible, most especially for those people who are desirous of knowing science, getting aware of who they are, where is the environment, and of course those things that are magical to become very familiar. So I thank you very much for your listening. Thank you once again.